Good day, everyone. Thank you very much for joining us today for today's webinar, Process Mapping. QSG is committed to providing you with up-to-date, useful, and credible information on the topics you care about. Thank you so much for taking the time to join us. We hope that everyone is safe and doing well. These are very difficult times for all of us, for our families, for our jobs, and we all hope that we get through this period quickly and you get back to normal operation and normal business. My name is Angelo Skengis, and I'll be the webinar moderator for today's program. Today's webinar is approximately 60 minutes. There will be approximately a 45 to 50-minute presentation, followed by a 10-minute question and answer session. Today's webinar will be recorded and will be available on our website soon. You should all have received a PDF document titled Process and Value Stream Mapping Basics. Jim Leonard put this document together based on class notes from the many courses that he has ran over the last few years. And this document was attached to the invite. If you do not have a copy, please take a look at the invite, and if you still do not have it, please email Chris at Quality Support Group, and he will email it to you. This document will be used by Jim during the presentation, and he will refer to it as he goes through the different areas of process mapping. I would like to point a couple of things out before we start. Everyone's phone and computer and/or computer will be in listen-only mode. We do this to minimize any background noise. We would like everyone's video, the camera, to be turned off so we do not stress the Wi-Fi systems now that everybody's working from home. We want this webinar to be somewhat interactive, and what we'd like to do is have you ask questions through the chat box located in the upper right-hand corner of your screen. Please type the questions as we go through the webinar, and I will collect them and announce them during the last 10-15 minutes of the webinar. So please feel free to ask any questions. So I think that's all. I'd like to do a quick introduction, and then we'll turn it over to Jim. So Jim Leonard is a consultant and an educator who specializes in teaching the principles of the late W. Edwards Deming as a new system of management. Jim has worked with manufacturing and service organizations throughout North America, Europe, and in China. He serves as the senior consultant for Quality Support Group in Westford, Massachusetts. For 29 years, Jim presented his seminars for the Division of Corporate and Professional Education at Worcester Polytechnic Institute in Worcester, Mass, where he also served as an adjunct instructor in graduate operations and industrial engineering. Jim works with clients around the world as an instructor. He also is a professor at the China Institute of Innovation in Shanghai. Jim is also an alumnus of the U.S. Naval Academy, where he majored in mechanical engineering and analytical management, as well as the George Washington University and Clark University. Jim resides in Ave Maria in Florida with his wife, Kate. They are the proud parents of 6 children and the grandparents of 10 grandchildren. And with that, Jim, thank you very much for taking the time to do the presentation, and I'll turn it over to you.
Okay, thank you, Angelo, and welcome to everyone. Angelo mentioned that document that was sent to you with the connection to be able to get onto the webinar. And I will be using some slides that are not in that document, but those that I use that are, it'll be keyed by page number. Also, thank you so much for signing up for this webinar, and feel free to use that document for internal training. We want to support you with your efforts to share this information with others in your companies, and hopefully you'll find that document to be helpful. One slide that's not on that document is our agenda. We're going to start out talking about adopting a systems perspective, systems thinking, process thinking. And by the way, anyone who has signed up for next Tuesday's Basic Quality Tools webinar, we're going to start out exactly the same way. I've always told people it's a quirk of mine. I refuse to leap into the how as it relates to process mapping or other statistical methodology without first reviewing the where and why we apply that methodology as it relates to systems thinking. So just be patient with me, but that's how we'll be starting out. Next, we'll go through just some basics, some process mapping terms and symbols that are summarized in your document as well. We'll take a look at some examples of process maps, both manufacturing and non-manufacturing. And then just kind of do a midway summary on a procedure for drafting the process map. But then, once we've defined the process with a process map, that may or may not really indicate what the true process is. So we're going to go beyond that and start talking about value stream process mapping. What can that add for us? Now, the process map has been around since dirt, and many of us have used it since then. Much of what I'll be sharing with value stream process mapping, going beyond it, I learned from a colleague who I worked with at Rogers Corporation 40 years ago, because he's old, Paul Hine, who was also a consultant for Quality Support Group as well. But in value stream process mapping, we're going to be talking about a value effectiveness ratio. Can we put a number on it? We can time how long it takes to take a process step, for example, to perform a transaction upon receipt of raw materials. But somehow we have to go beyond that. What was the cue? What was the actual time before I got around to the transaction? How long did that material continue to sit, making no progress through the process after I performed the transaction? And so that's what value stream process mapping does for us. It exposes waste that may not be obvious on the original process map. We'll then go through step by step, and we did provide this in the document for you to share with others, a procedure we recommend for drafting the value stream process map. And then we'll wrap up talking about some, why do this? Why incur this pain? What are the benefits that we've seen among some of our clients from process mapping and value stream process mapping? And then, as Angelo said, we'll try to leave plenty of time for questions, as well as it would be interesting, some of you can unmute yourselves and tell us about your experience with process maps in your organization. So in terms of systems thinking, questions we want people to be addressing, it all begins with the question, who are my customers? Who uses what I produce? Who uses what I pass on? Question two, what are their needs? If I don't know, I have to go ask them. And needs, not hopes and wishes. Thirdly, how can we best meet those needs showing minimal variation, very consistently, delivery to delivery of my product or service to that internal or external customer? How can I show that? And continuous improvement as measured by reduced variation over time, ever more improved consistency and predictability. How are we doing? What can we do better? And in seeking answer to the question, what can we do better? All of us has a choice. We can choose to focus on the quality of our products and services. Or we can choose to focus on the quality of our processes that produce our products and services. We cannot do both. And if anybody ever asks you, why can't you do both? Just remind them, hey, I work at XYZ company. We have limited time, limited people, limited resources. None of our customers are ever going to give us a blank check. We've got to pick our poison. On what will we focus those limited resources? The quality of our products and services, or the quality of our processes that produce our products and services? Because we can't do both, and we'll never be able to do both. And what I recommend to you would be to put together, at the risk of oversimplifying it, put together a little series of oil and pipe slides. I've used these in my workshops for decades. In this analogy, our product is our oil. If all goes well, it comes out, it's good, we can accept it, we can put it in a barrel, we can ship it, and we can make money with it. Our process, and I'll use the terms process and system interchangeably, our process is the piping system through which the oil passes. And let's say, for the sake of illustration, at your companies, we choose to put our focus on the quality of our product, the quality of our oil. We want to make sure that product is good versus design specification, downstream customer needs, market demands, customer requirements. That's what we're focused on, is to make sure we have good product. A couple of weeks later, out in the middle of the desert, the pipe cracks. Dirt, sand, contaminants get into the oil. From our product quality focus, we achieve organization-wide consensus. We have a product quality problem, dirty oil. We can't accept it. We can't ship it. We can't make money with it. From this product quality focus, what corrective action will we take? And you might pose that in your internal training and be prepared. Somebody in your class is going to say, well, fix the pipe. But then you'll remind them, we're not looking at the pipe. We're looking at the product. So what will we do? We'll slap on a filter. The filter serves to detect and screen out the contaminants. Now the oil's good again. We can accept it, we can ship it, we can make money with it. But please note, that filter in and of itself does nothing about the root cause of the defects back in the process. In the vocabulary of the systems perspective, this filter adds no value. All it does is get the product back up to where it should have been all along when it first came out of the pipe, but it adds no value. What are some of the non-value-adding filters we've installed? In Western management? Well, in manufacturing, inspection. Inspection adds no value. I don't mean to offend any of your inspectors, but they add no value. Because that product's already good or bad by the time we inspect the products. So we perform inspection, we find some defects. Sometimes we can rework it, we can salvage it, but rework adds no value. All rework does is get that product back up to where it should have been all along when it first came out of the process. See, in manufacturing, we call these non-value adding filters inspection and rework. In new product development, it's test and revision, or ECOs, engineering change orders. And here's the case. In new product development, are all ECOs, I'll call them ECOs, are they all non-value adding filters correcting a flaw that came out of the new product development pipe? No. In the product development and R&D people I've worked with over the years, only about 75 to 80% of them are non-value adding filters, rework kinds of ECOs, correcting flaws that came out of the new product development pipe. The other 15 to 20% are appropriate responses to changing customer requirements and technology. So what's the challenge facing those new product development people? How can we improve our new product development process? How can we clean all of those non-value adding rework ECOs out so we have a more timely, more responsive mechanism to changing customer requirements and technology? But though these filters don't add value, it worked. For decades in Western management, this focus on product quality, this striving to become ever more efficient in AQL sampling, inspection, and rework worked until we entered this new economic age. And discovered on occasion the filter gets dirty. We weren't quite sure why or when. So in Western management, we created QC people. And we told them, stand at the end of the pipe and look at the product as it comes out. If it's good, put it in the accept barrel, we'll ship it and make money. If it's bad, put it in the reject barrel, call maintenance, and have them change the filter. And then we added redundant inspection and audit. Hi, I'm from corporate, I'm here to help you. Whose job it was to determine if that which we deemed clean was indeed clean, if that which we deemed dirty was indeed dirty, and if the filter was changed and scheduled. And one beauty of this redundant inspection and audit that has evolved from this product quality focus, one beauty of redundant inspection and audit is no one's responsible. That's the beauty of it. Those managing the pipe aren't responsible. It's a job of the inspector to check it. After all, they have quality in their job title. I don't. The inspector's not responsible. It's your job of the auditor to catch it. The auditor's not responsible. It's your job of those working in the pipe to do it right in the first place. Right first time, every time. Give me a t-shirt, it'll happen. And we end up with finger pointing, hate, blame, place, and discontent, and excuses. And in our society, not work alone, in our society, it's so much easier to engage in finger pointing, hate, blame, place, and discontent, and excuses than it was to work on process improvement. And at the risk of oversimplifying it in all of its complexity, all Dr. Deming was getting at to his dying day, at the age of 93 in December 1993, he was asking us to sit together in a webinar like this and ponder on this slide for a nanosecond. And in doing so, to recognize all the non-value-adding filters we install, all the value-adding resources we invest in this product quality focus on quality that add no value. All of our quality technicians are value-adding resources. They could be out there on the line, making sure that work methods documentation is up to date and user-friendly. Assisting supervisors in training new operators, assisting supervisors in upgrading the skills of experienced operators. But whenever we have them locked in a mass inspection filter, they add no value. They're value-adding resources, but due to lack of knowledge management, deploys them in a fashion that they add no value. And what Dr. Deming was saying was, management, learn your job and shift the emphasis. Shift the emphasis from product quality to process quality. Develop the strategy, derive from that the annual plans. Within those annual plans, provide the training, the tools, the methods, the direction that people might shift their emphasis from product quality to process quality. As soon as we do that, they'll see the crack. As soon as they see the crack, they'll patch the crack. As soon as they patch the crack compared to what it was, they will have improved not only the process, but all of its future outputs. So the challenge facing people sitting through this webinar and related training is to head back to work and encourage, not get into the methodology yet, encourage our employees and coworkers to strive continually to understand, maintain, improve the quality of their process, the quality of their pipe. And if we're able to do that, 100% of the oil will be good. There'll be no need to filter it. Of course, we can't be out there selling snake oil and saying TQM, TQC. It's all going to be wonderful. It's not going to happen short term. Late 2000, a client named Biocompatibles emerged from their R&D labs in England from 15 years of biomedical research. And they decided it's time to go commercial. It's time to start to produce and market this proprietary coating technology we've developed throughout the worldwide medical devices marketplace. And they decided our strategy for making that painful transition from 15 years of biomedical research into commercialization is we're going to implement a Six Sigma initiative. That was going to be the methodology they used. And I had the honor of working with their senior management team and then their initial project teams and their operations in England, Ireland, and Virginia. 12 months later, 100% of their oil was not yet good. In their Norfolk, Virginia operations, they'd only gone from 65% first pass yields to 94% first pass yields. They still had a lot of work to do. 100% of the oil wasn't good yet. I'm not here to sell snake oil. No one can question the progress they made, but 100% of their oil wasn't good yet. But what makes their progress most impressive to me, over the same period of time that they accomplished this unquestioned progress from 65% first pass yields to 94% first pass yields, they went from 2 cast molding lines to 9 cast molding lines. From 85 direct labor employees to 320 direct labor employees. From producing and shipping 200,000 compliant packaged units a month to producing and shipping 1.6 million compliant packaged units a month. It's one thing to take these powerful tools, all the basic tools, process mapping, more advanced tools, design of experiments, and apply them to a pretty steady state operation to accomplish some impressive gains. What makes their progress most impressive to me, they went from 65% first pass yields to 94% first pass yields. Over the same period of time, they experienced a 4 to 8-fold expansion in production capacity, employment, and shipping levels. But 100% of the oil wasn't good yet. And the challenge facing everyone who goes through this type of training, everyone you train, is to head back to work, take advantage of every opportunity you encounter to contribute to the strengthening of a healthy work environment throughout your organization, in which whenever anyone says the word quality, you don't just want some picture of a high quality product meeting all design specifications to pop into people's minds, nor do you want a picture of the quality group's monthly summary of rejects broken down in Pareto diagram format by reason for reject to pop into people's minds. No, whenever you say the word quality, bam, you want this picture to pop into people's minds. This holistic model of the process that physicist Walter Shewhart came up with at Bell Laboratories back in the 1920s. His concept being most of the problems, most of the failures, most of the variation, waste, cost, loss you find at the output of any and every process, most of it was produced by the process itself, made up of what Dr. Deming later labeled common causes of problems, failures, variation from within the process. Some traceable materials, machines, methods, people, measurement systems. And intuitively, intellectually, you share this with people. They're going to say, hey, you had to sit through a webinar to learn this? Everybody knows this. We can have the best trained, hardest working people in the world in production in our company. If we get garbage raw materials in from a supplier, what comes out of our production pipe today? Garbage. It's so obvious. And yet, despite the intuitively obvious nature of this model, many people have months of work ahead of them to help people to think this way, to get this holistic model of the process to pop into people's minds when you say the word quality. Because we've been subjected to, we have experienced. We've come to accept a completely different model. I like to call it the process model from the age of mythology, and there it is, person equals output. Now, we need not go into the intermediate analytic statistics that Walter Shewhart invented upon which he built his rational model. Just draw upon your own experience. Encourage your trainees to personalize this. Go back to your own careers, beginning with your first part-time job in high school. Have you ever had an immediate supervisor whose first question, when he or she has first encountered a problem, has been, who's responsible? Give me a name. If yes, welcome to the age of mythology. Have you ever worked for a company that a majority of their corrected action reports read, spoke to operator and told him to be more careful, or scheduled operator retraining? If yes, welcome to the age of mythology. And the tools we apply to learn about these, the tools we apply to continuously improve these, are the essential statistical methods, the second key element of the transformation process. And there are some very powerful basic tools where everything begins, and then we go on, depending on the scope of the project or process, with more intermediate or more advanced tools. And this basic procedure for improving a system, any system, this is what the cross-functional process improvement project team goes through, from initial formation to dramatic breakthrough process improvements. And some of you may have had Six Sigma training and learned about Six Sigma DMAIC. DMAIC sounds demonic. Define, DMAIC, define, measure, analyze, improve, control. The 5 phases of a Six Sigma process improvement project. How does the Six Sigma DMAIC rubric lay over this procedure that was around at least 10 years before Six Sigma even existed? Because I'm old. The first 2 steps in this procedure, we'll call it D, define. Define the system to be improved. It all begins with the process map. Define your key measures and operational definitions. And we move into M, measure. Measuring is more than gathering the data. We also have to check and assure our measurement system capability. Once we have the data in hand, A, analyze. Is the process stable? If no, engage local workforce personnel to perform the root cause analysis to find, remove, prevent the reoccurrence of the special cause. Once stable, work to identify potential system changes for improvement. Having done so, I, improve. Implement the proposed system improvement, preferably on a small scale or pilot basis. Continue to monitor the system output for improvement based on the key measures you defined at the time you drafted your process map. And then once capable, control, lock in that control plan, hold those gains, go on to work on something else. So, and it all begins with the process map. But if we want to deploy this process, this procedure for improving a system. Dr. Deming always said the first step to improving a system is finding out what's wrong with the current system. That is where the process map comes into play. That is why the process map is the first tool we use in all process improvement projects. And I might add, many 8D problem investigations, safety incident investigations, etc. And one thing we have to do is to make sure that we initially map the process as is, with all of its warts and imperfections, because the reason we're doing this is to first find out what's wrong with the current system. Too often, people end up with an initial draft of their process map that's kind of a combination between how the process is and how we'd like it to be. But it's really neither how the process is nor how we'd like it to be. So in drafting the process map on page 2 of your document, process mapping symbols, now you can go online and find a gazillion different symbols. I kind of stick to some basics. Kind of a football shape is the beginning or the end of a process. An activity, something that advances the work, that adds value, that's a rectangle. Sometimes it's a decision point. Maybe this is a go, no-go decision. Maybe it's an inspection point. That shows up as a diamond. If we're going off the page to another process map or another page, just a circle to show that connection. Flow lines connect and tie everything together. And then some people like to use a kind of a lightning flash to show an improvement opportunity. Now, I want to show you a map here that I don't ever want you to draft. This guy actually put this online. Boing, 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 boing. Whoa, look at all those improvement opportunities. I mean, you start out with something like this, people's eyeballs are going to roll back in their heads. They're going to say, oh man, what are we supposed to do with this? And this is an error that's being illustrated that you have to avoid like the plague. Brian Joyner, who was a Deming master back in the 80s, always recommended to always start with a process, not the system. This is a distribution system. Replenishment is a process. Case pack is a process. Receiving is a process. You got to manage your scope and always focus on the process, not the system. Manufacturing is a system. Coding is a process. Functional test is a process. It doesn't add value, but it's a process. Assembly is a process. Always start with the process. Manage your scope. So that you're not overwhelming people or getting people bogged down or breaking their hearts at the outset. Because you can't eat that elephant. You can't eat that distribution system, but you can't eat it all at once. So here's an example, more of a process. We send an order out to a supplier. They package it, they ship it, we receive and unload it. Then we go through some sorting, maybe some kitting, and some assembly at our distribution center. This team decided that's our focus, that's our improvement opportunity. Because guess what? We don't control the supplier's distribution center. There's really not much we can do about that short term, but here's where we're going to start, our kitting and assembly processes. So some process mapping terms on page 3 of your document. First, a workaround. What is a workaround? These are things that our brilliant operators come up with to make our sorry process work. It's not documented anywhere. It's not on an SOP. It's not in any process maps. Your initial process maps must include all workarounds, because that does show the process as is, current state. So you got to go out and talk to people and make sure you include those workarounds on your process map, because again, you want to have it as is, with all of its warts and imperfections, because the first step to improving a process is finding out what's wrong with the current process. Here is an overview as-is process map at a client. Their process improvement project was to improve shipping performance. So they just started out with an overview process map. Okay, we get incoming components, followed by QC inspection. If it fails, we send it back to the vendor, or we get a deviation to use as is. If it passes, we go on to an auto insert operation, followed by QC inspection. If it fails, we rework or scrap it. If it passes, on to hand assembly, followed by QC inspection. If it fails, we send it back to hand assembly. If it passes, on to wave solder and cleaning, followed by QC inspection. If it fails, we rework or scrap it. If it passes, on to post-assembly touch-up. I found that fascinating. Not only do we assemble it, but 2 steps later, with 2 QC inspection steps in between, we post-assembly touch it up, followed by QC inspection. If it fails, back to post-assembly touch-up. If it passes, on to an auto test for functional performance. If it fails, rework or scrap it. If it passes, ship it. share this with people and ask them, see any filters in here? See any non-value adding filters in here? Now, the process engineer who served on this cross-functional team, she took their draft back to her coworkers in manufacturing engineering, and they were ready to lynch her. They said, that is not the process we transferred. That is not the process we validated. And they were right, but so was the team. Because over time, as defects occurred, they just kept slapping in these QC inspection filters. So how did the team start? Right here, QC inspection after hand assembly. They had file drawers full of reasons for rejects after hand assembly. They worked their way back up into the hand assembly pipe. They identified and addressed the major causes of those rejects. And by the way, it was in hand assembly where they introduced their first statistical process control chart in the plant. They went to assembler self-inspection and maintaining their control charts, and they eliminated that QC inspection step. Then they went after post-assembly touch-up. Not only what are the causes in post-assembly touch-up of QC rejection after post-assembly touch-up, they also went back into wave solder and cleaning and hand assembly to say, okay, what are the major causes of the need for post-assembly touching it up? They followed through on their improvement plans, and they were able to completely eliminate those two steps, reducing lead time and reducing cycle time, improving on-time delivery and shipping performance every step of the way. So that's an as-is process map. Another thing, we'll talk about this later, a should be, or sometimes called a future state process map. Sometimes teams will say, well, let's blue sky this. What do we want it to look like? Again, that's in your document. We'll get to that later. Another thing, bias that you have, in addition to as is, overview. Stay out of the weeds. Don't go to the nth detail. Save your energy for what you're going to need to improve in your work to improve the process. This on page 5 of your document is just an overview process map of the preparation stage for getting started on the transformation process, providing leadership with an introduction, then providing education, form some steering committees, draft and publish your mission statement and implementation plan, and communicate it. Not going into the details of the communication meeting schedule or any of that. And the other overview process map we looked at earlier, this printed circuit board production, as is. And Paul Hine always stressed when you're doing your initial process map, if you have more than 10 to 15 steps, by that we mean these rectangles that advance the work. If you have more than 10 to 15, one of two things might have happened. Either your scope is too broad, or you've fallen prey to the detail monster. So that's our advice. As is, overview. There's also a top-down map on page 6 of your document. This was taking on a corporate recruiting and employment process that just took too long to fill exempt professional and managerial job openings. There were 3 stages: preparation, recruiting, selection. And then dropping down from each of those were the more kind of overview, but still what were the more specific steps taken as they advance from approval of requisition all the way through when the new employee starts work filling that job. That's a top-down map. And then sometimes we'll go into a detail. For example, that team that said, okay, let's go after assembly, followed by QC inspection. What was going on there? They certainly went more into detail in the assembly process on their overview process map. But here's one that's going to the nth detail of selecting the appropriate control chart. Because, you know, I can put counts data into the computer, call up an X bar and R chart, and the computer will give me an X bar and R chart. It won't be valid. So this kind of goes through, okay, first, what are my key measures? Am I measuring or am I counting? If I'm measuring, variables type data, construct the histogram. Is it bell-shaped? Does it appear to be normally distributed? If yes, am I dealing with slowly evolving data? If yes, I go toward the individual's chart. If no, I go toward the X bar and R chart with small subgroups. If no, it's not bell-shaped, am I dealing with slowly evolving data? If no, I'm going with the X bar chart with the larger subgroup sizes. If yes, moving average, moving range chart, all flowing down into the tests we perform. If I'm counting, notice again the connector onto page 8 of your document. Am I counting defects Or am I counting defectives? Good, bad, pass, fail. If I'm counting defectives, is my sample size, my area of opportunity to find a defective held constant? If yes, I can go the NP chart route for number of defectives. If no, I go with the P chart for percent or proportion defectives. If I'm just counting defects, is my area of opportunity to find a defect, my sample size held constant? If yes, I go through the C chart for count of defects. If no, I go through the RU chart for rate of defects. So they're going really into the nth degree, step by step, a detailed process map for making sure I'm selecting the appropriate control chart. So that's just introductory, spending a lot more time on process thinking, because that's important to plant that in people's minds, than the symbols and so forth. But generating the process map, pages 9 and 10 of your document. First, we assemble the team. G, who should be on the team? The process is the boss. The process will dictate who should be represented on that team. This is typically a small tiger team, although if I am in a broader process improvement project, maybe more complex processes, I'll need more members. We want to make sure we have good cross-functional representation with process people at the table together with supplier, internal supplier, and internal customer representation. And we also want to assure input from local workforce personnel, as Dr. Deming referred to them, people who work in the process. And for example, let's say you're on a safety investigation, an accident. If it wasn't a lost time accident, the injured employee is on the team. It's not optional. We need that. So we assemble the team, then define your process boundaries. Where does it start? Where does it end? And then create your as-is overview process map. Again, stay out of the weeds, as is. Then Paul Hine always recommended stop. Okay, are the beginning and ending steps of the process appropriate? Are we spreading it out too far? Are we focusing too narrow? Is the process of reasonable size, or should it be broken down into sub-processes? Do we have the right people on the team? Is there anybody else whose input we need? Do any glaring points jump out at us? Sometimes we do that initial process map. Somebody's looking at one of those process steps and says, why do we do that? Where did that come from? You know, I'm really not sure if that adds much value. Then we actually, after drafting it, go out and walk the process step by step, follow it right through. And doing so, interview the process, both people and things. How do I interview a thing? Well, that's back to, where did this process step come from? Note cycle times, rework loops, distances, potential hazards, etc. Keep it simple, keep it fast moving. You can always go back and make changes. It's not carved in stone. Now, for our last 10 minutes or so, that's the process map. As is, we think. As Yogi Berra once said, in theory and practice are the same. In practice, they are not. We've got that process map drafted. We're showing how long it takes to take each step, but is that the true process? Is that the true cycle time? Here's where we go on to value stream process mapping. And two authors, Rumler and Branch, years ago wrote a book about white space. They introduced the concept of white space. So in the organization chart, we have our general manager, we have the new product development manager, operations manager, quality manager, analytical lab, packaging and distribution. And Rumler and Branch pointed out, we manage top-down. Management flow is top-down. But customers are served horizontally. Think about the new product development project and how it cuts across various functional boundaries. And what they said was, there's all this white space that our process flow has to cross that's not being managed. We manage top-down. We serve customers horizontally. And so Rumler and Branch noted that most organizations by design are dysfunctional. And they introduced this concept of white space. And management's job, see, it's in this white space where a lot of the waste is hiding. And Peter Drucker noted that management's job is to accomplish the monthly abandonment of waste, the monthly reduction of variation. If a manager at the end of the month can't show documented evidence of the elimination of waste, he or she has not done their job that month. That's what Drucker was saying. So if we want to attack, reduce, abandon waste, first we have to expose it. How do we expose it? You got to go get some data. So here we are, just a receipt of material to issuance to the shop floor. It takes a couple of minutes to physically receive the material, get the document from the trucker. Then we transact it, we scan the barcode, takes a minute. Then we do a quick inspection, make sure there isn't any obvious damage to the packaging. Then we move it over. It takes us about 5 minutes on the forklift truck to put it into the warehouse. Later, in accordance with the production schedule, it takes us about 5 minutes to pull it back off the shelf, an additional 5 minutes to move it out to the shop floor. So we add all this up, we're looking at value adding of 15, 25, 28 minutes. But what about the white space? That's where the waste is hiding. How much queue time is sitting where that received product is not advancing at all. And again, to expose it, we need data. In God we trust, all others must bring data. Karu Ishikawa's reminders for collecting data. First, clarify the purpose for collecting the data. Why are we collecting these data? Are we all on the same page? Second, collect data efficiently. Ishikawa long insisted. Duran and others in this country long agreed with them. And the vast majority of process improvement initiatives, regardless of enterprise, we already have all the data we need available to us as prior in-house data. Go get it efficiently. Where do things break down in American managed companies? Ishikawa's third reminder for collecting data: always take action according to the data. And I choose to take that reminder literally. Literally. What was Ishikawa saying? If the data you're collecting results in no action, stop collecting the data. If the data you're collecting results in no action, stop collecting the data. So with these guidelines in mind, meaningful and actionable data, beginning on page 12 of your document. First, time. Not only the time to do the transaction, it takes me a minute to scan the barcode. The amount of time that received product sat before transaction and continued to sit after transaction. Distance, percentages, percent scrap, percent rework, etc. First pass yield. This is the percentage of product that makes it through your process in order with no rework, no massaging, and no workarounds. And Paul Hine always said, this is the best measure of a process. And again, that's why it's important to go out in your initial process mapping and include those workarounds. You have to map that process as is. Next, costs. Joseph M. Duran, Deming's former coworker and contemporary, left us this advice. He said, when dealing with management, use the language of management, the language of money. You may need some resources to fix and improve your process. Make a good case for those resources by reporting not just scrap percentage, scrap cost. Not rework time, rework labor cost. Not repeat test labor cost. Don't BS, don't exaggerate, don't get political, just the facts, ma'am. But use the language of management, the language of money. Queue and wait time. This is what's hiding in the white space to end up with true measurement of cycle time. We looked at earlier, now on page 13. This team took on the last 130 professional and managerial jobs filled from approval of requisition to when the new employees started work. The overall cycle time on the average, it took a little over 5 months with a range of 30.2 months. And the belief was always, well, most of it just it's in this recruiting stage, takes forever. That's where most of the time takes. I mean, once we see the right resume, we and the hiring manager move very quickly. So they decided to challenge that. In God we trust, all this mustering data. So they said, okay, they took a look, these 130 jobs. From the time the resume was received, and remember, it takes the HR person a couple of minutes to look at it, to when it got to the hiring manager, average 3 days with a range of 10 days. Then the hiring manager looks at it, and remember, this is a person he or she ended up hiring, and gets back to HR to say, okay, schedule an interview with this person. The average was 9.1 days with a range of 47 days. No one ever would have believed that. Some hiring manager sat on the resume of the person he or she ended up hiring for more than 1.5 months. That was the range, not the average. Then it goes back to HR. We have to arrange an interview. That average was 19.2 days, almost 3 weeks, with a range of 50 days. We do the personal interview. We decide, do we want a second interview and/or are we going to make a job offer? That was an average of 19.5 days with a range of 46 days. And finally, from the time the job offer was accepted to when that new employee showed up to work, the average was over 30 days. They have stuff they have to do before they show up with a range of 47 days. Just the selection stage, the internal selection stage of the process averaged 2.6 months with a range of 4.4 months. And the total cycle time was 5.05 months. More than half the time was taken in this internal selection stage. But until they exposed it, before they went into the white space, nobody ever would have believed this. We have two species of time we have to address here if we want to dramatically reduce the time it takes to fill future job openings. One species of time is the time taken in preparation or recruiting. A second, completely different species of time is the selection. And then we can put a number on it with a value effectiveness ratio, which is the value added, the actual time it takes to advance the work, divided by the total true cycle time. Paul pointed out to me, now people are talking more about processing time because some people get offended if you tell them they had no value, divided by total cycle time. So back to that process of receipt of material to issuance, they found, well, it takes us about 28 minutes to actually advance the work. That's the processing time. But on the average, always on the average, the material sat for a day between receipt and transaction, 2 days between transaction and moving it and inspection, another day, 60 days. That material that we paid for sat out there on that shelf doing nothing before it got pulled for a work order. Took about a half a day, not 5 minutes, not 10 minutes, a half a day to get it out there to the shop floor location. And there's a kind of a value effectiveness ladder you can put across the top. Across the top is the white space. The white space, the queue time, the delays. Across the bottom is the actual processing time. And in this case, actual case I might add, the actual processing time was 28 minutes. Doesn't take us long at all to receive something. The total cycle time was 64.5 days and 28 minutes for a value effectiveness ratio of 0.09%. In other words, 99.91% of the time of that process is waste. Nothing's moving, or 99.91% of the time, this process adds no value. I'll tell you, when you start to expose some of these things, you've got to do this initially, otherwise people won't believe it. They wouldn't even believe it. So, wrap up, drafting the value stream process map. Go back to the guidelines about forming the team, having the right people on the team. So put your sticky notes at the beginning and ending steps on the left and right of your whiteboard, and then step back and start to discuss good metrics. What do we want to be thinking about as we map this process? Yields, scrap rate, cycle time, rework percentage, rework cost. There's no penalty for guessing. Sometimes it's very healthy because somebody says, oh, no, we can do that in a day. Somebody else says, no, that takes a month. Wow, that's a real discrepancy you have to address. Then starting from the beginning step, again, we're pretty much following the early one. Post your sticky notes, major steps of the process. After you do that in sequence, remember it's an overview map. It's the current state as is. It's always okay to remove and reorder and combine your steps. But remember, if you end up with more than 10 or 15 steps, more than 10 or 15 rectangles that advance the work, beware. You might have fallen prey to the detail monster, or your scope is too broad. After we post those sticky notes of the major steps of the process, sometimes it's instructive to go backwards through the process. But what are you doing? You're starting with your customer, internal or external, and you're moving back through your process from his or her perspective. Post approximate processing times, wait times, rework loops, other inherent or suspected problems. But remember, most of your cycle time is hiding in the white space. Also, note the time it takes on the average. Don't go with the extremes. Wow, one time that thing went so smoothly, it took only a day. Another time, everything that could go wrong went wrong, and it took us 5 months on the average. On the average. And then go out, walk the process, review and update the map and key measures, and select your first targets for your first improvement efforts. Future state or process maps. So, gee, what would we like the process to look like? And it could be created if the process can't be improved or it's a new process from scratch, but they can be dangerous. It could take more time to do it. It could take more cost. You also run some political risks. You're basically going to that process owner and saying, hey, your baby's ugly. You know, you might not want to run that risk. Most future state maps never get implemented anyway. In fact, I've never seen it. A team that has put together a future state map, once they complete their project, what the project process really looks like isn't their future state map. And that's why I always recommend just focus on the as is and work to improve the process. And then in terms of simplified, Paul Hine told me that 50% of reduction time in cycle time is normal, not extreme, normal. This also changes how management operates. It requires new approaches to thinking and planning, because Albert Einstein told us the thought process that got us into the problem can't be used to get us out of the problem. We've got to adopt different thinking. It's data and fact driven. And you need that baseline measure when you're doing the initial process mapping and or value stream process mapping, because without that baseline, nobody's going to believe the improvement you accomplish. If you don't do it at the beginning, it's too hard to go back and do it later. Benefits of process mapping: it yields an understanding of the process steps and procedures. It helps to clarify complex processes. It exposes sources of waste, redundancy, cost. I mean, especially when we're looking at that initial draft and saying, why do we do that? Where did that come from? Provide the basis for improving, targets for simplifying and or streamlining the process. It exposes causes and sources of variation and waste in process outputs. It is an excellent means to document and communicate business processes and procedures. It will generate cost savings when we follow through. You got to take the action. Always take action according to the data to eliminate the unnecessary redundant tasks. And bottom line, learning. Every time you engage a team or even an individual in mapping a process, he or she will be learning. So, thank you for taking the time to sit in on this webinar. Questions, comments, curses? I'll turn it back over to Angelo as moderator.
Thank you very much, Jim, and thank you for the excellent presentation. Every time I listen to you, my brain is really set on how we improve our processes. So that's a great thing that we are thinking about for sure. So thank you for taking the time to present.
Yeah.
So we have a series of questions, all very good questions. One of the questions that came in was relative to page 5 of the PDF document that we sent out. And this question was around the importance of planning. The question was that many times we fail to execute an effective process mapping exercise because we don't plan properly. Can you just please talk a little bit about some of the things that we need to do, some of the important things that we need to do ahead of time before we get in the room and start mapping?
Oh yeah, well, and also, I mean, let me take it back even further. I always recommend to people, take a look at the current strategic and or annual plans for the organization or the plant or the department. Where can this process improvement effort mapping exercise, what are some existing documented objectives that we can apply? Don't be adding things. Well, gee, let's go work on this process. It's not related to the annual plan, because people are going to be very hesitant to provide you resources to do that. But secondly, the idea of before meeting with the team, before even forming the team, I might add, the person who's owning this, who's driving this, might just want to sit at his or her desk and do an initial overview process map on their own, and then just go out and walk the process on their own. Because that is going to give you the opportunity not to control the mapping exercise, but to guide it. So the pre-work on the part of the team leader is always very critical for helping a team get off on the right foot.
Thank you, Jim. The next question, there's a bunch of requests that we make your presentation available to the attendees. And with your permission, I'd like to send out a PDF to everyone. Is that okay?
No problem. I'll send you all of these. I did mention some of the things I was using was not in the document, but sure, be more than happy to share them and encourage. And we're always flattered when, I'm always flattered when clients choose to use our material for their internal training, because that's,
Right.
we want to help them in that regard. So I will send you the complete set of slides,
Yeah.
including the oil and pipe.
Sure, why not?
Okay. Because that's my super secret.
Our aim is to provide as much value as possible, right? That's
Okay, boss.
That's what QSG is all about.
Okay.
So the other question, Jim, a couple more questions. One question came in concerning process mapping software. Do you recommend using software system to map the process, or do you prefer like the sticky notes on the wall type of an approach?
Well, our attendees don't know that answer. You know that answer, Angelo. I don't even use software teaching design of experiments. I don't understand computers. I don't like them. I don't like people who work with them. Other than that, I'm open-minded. But no, I much prefer, I mean, you can use your software after the fact to document, because that makes it easier to send around electronically. But the actual mapping exercise, the Post-it notes or the whiteboard, because those of you who have done these, you've seen the same thing I've seen. You actually see team members getting out of their chairs and touching the whiteboard. They are engaged. Whereas if someone is on the other side of the table with a PowerPoint slide, tapping on computer keys, I just haven't seen that engagement. So I was being facetious about I don't like computers. No, I wasn't. That's true. But yeah, definitely use it to document and distribute electronically the resulting process map. But the actual drafting of the process map, please follow the procedure we recommended with a whiteboard and or those Post-it notes, because people really stay engaged. At least that's been my experience.
Very good. I knew the answer to that, but I had to ask.
Yeah, that's right. That's what you get for hiring old people.
Another question has to do with somebody asked about struggling with doing a process map because of the need to go to perfection in terms of the as-is map. Can you comment on that, please?
Yes, and it's a great question, because this is, I mean, nothing gets project teams bogged down more than this key question. Overview, overview, overview. The more detail you go into, the more likely you're going to end up with anal boy. You know, oh, no, that's really not how we do it. I mean, keep the overview process map. What this question is directly related to the number one reason project teams get bogged down at the outset and team members lose heart. And the way you combat that, especially if you're team leader or facilitator, overview, overview, overview. Just let them know, no, we'll go into the details later, because this is what sucks the energy out of the team. And I think I mentioned earlier, if I didn't, let me repeat it. You want to save your energy for the work you're going to have to do to improve the process, not suck it out of all the team members to end up with a highly detailed initial process map. So I hope it doesn't sound like I'm avoiding that question, but overview, overview, overview.
Very good.
And I really do. I mean, Paul Hines' recommendation was always helpful to me. More than 10 or 15 steps, beware. Beware. You know, step back. Maybe our scope's too broad, maybe we're falling, because the more detailed you get, the more arguments you're going to be engendering.
Very good. Thank you, Jim. And finally, we have one more question, and it is something that I think a lot of us struggle with after a process mapping exercise, and that is we don't follow through effectively. The actions are not implemented. And we do the map, everything looks great. We know we have, but then it just seems to go in different directions. Can you please comment on your ideas in terms of maintaining the momentum and following through with the actions as identified in the process mapping exercise?
Okay, another great question. This, by the way, largely goes back to the first question about the planning. we give these teams a lot of responsibility. They have no authority. They have no authority to go in and say, oh no, we're going to do it this way. Oh no, analytical lab, we want you to go on this schedule. And that's why you have to make sure, if necessary, you're even recruiting a sponsor at the outset. Make sure you're strongly engaging that process owner, the manager, not team member, so that you have that go-to person, so that you can escalate these issues to someone who has the position power to take the action. But the other thing I would recommend is getting back to Duran's point about the language of management, the language of money. There was a VP of quality I worked with many, many years ago at Millipore, a guy named Greg Sam. He encouraged, because this is not only process mapping, this is FMEA, this is new product development, everywhere this shows up, all these project teams that have responsibility but no authority. This was not a requirement of their quality management system. He strongly recommended to all these teams, try to express at least two of your effects in the language of management, the language of money. Because he was saying to the engineers in this case, he was saying, look, you're right. A lot of times you don't get sufficient resources to follow through. You're right. I hear you. That's not an empty question. That's not an empty complaint. But he said, he pushed it back on them a bit to say, a lot of times you don't make a good case to get those resources. Use the language of management, the language of money. As I mentioned earlier, not scrap, well, report scrap percentage, but on top of that, scrap cost. Another thing I recommend sometimes, what would the sales value of that scrapped product be? That's not BS. That's not exaggeration. There's the amount of sales value that we lost. So then we're in position to say to the process owner or others that, okay, pay me now or pay me later. Give me the resources to follow through on this change, or continue to suffer these documented costs forever. But the other point, let me make one more point. This again pushes back on the team. The procedure for improving a system, any system, the part that has to do with the improve phase, implement, preferably on a small scale or pilot basis. Don't go crazy. Don't go back saying, give me the resources to blast this thing through the entire plant. No. I know this operator pretty well. He or she really understands this machine. Let's test this thing out and verify it on this machine. Then we'll worry about expanding. So some of it is also the scope of your recommended action, preferably on a small scale or pilot basis, because that's where you earn a lot of support by saying, look, we did it here with Charlie on machine A, and look at the reduction in the improvement in first pass yield. Bang. So I guess I answered that 3 or 4 different ways, because there's never any one answer to questions as good as these.
Very good. Thank you very much, Jim. And with that question, this concludes our webinar for today. I want to thank you again, Jim, for an excellent presentation. And I want to thank everyone that joined us for the webinar today. We hope that it provided value to you, and it's something that you can take to your organization and improve your processes. Please follow us on LinkedIn or Facebook, qualitysupportgroup.com. On our website, we also list the other webinars that we'll be running in the near future, and we look forward to seeing you again. And before I finish, I think I speak correctly, Jim, that you wouldn't mind any questions even after the webinar is done. And you can email Jim directly at jim.leonard@qualitysupportgroup.com.
Oh yeah, feel free to get in touch at any time. And next week, as I mentioned earlier, the basic quality tools, it will be starting out with the oil and pipe, because that's how you always start. But then beyond process mapping, we're going to be looking at some of the other, they're called basic tools, but they're still extremely powerful.
Right. Basic quality tools, Jim, is running when? I'm sorry?
Next Tuesday, April 14th at 11 a.m.
Perfect. Thank you very much, and hope to see everyone at a future webinar. Have a great day and stay safe, everyone.